Atoms are the fundamental building blocks of everything around us. Picture this. At the very center of each atom lies the nucleus, a tiny but incredibly dense core. This nucleus is made up of protons and neutrons. Protons carry a positive charge, while neutrons are neutral, meaning they have no charge at all. Together, they account for almost all the mass of the atom. The number of protons in the nucleus defines the atomic number, which tells us what element we're dealing with. For instance, carbon has 6 protons, giving it an atomic number of 6. Now, surrounding this nucleus is the electron cloud, where things get really interesting. Electrons, which are much smaller than protons and neutrons, carry a negative charge. They don't just float around randomly. They occupy specific regions called orbitals. These orbitals are defined by quantum mechanics and can be visualized as clouds where electrons are likely to be found. Imagine a busy city where the electrons are constantly moving, zipping around in their designated areas. Let's break down the subatomic particles a bit more. Protons weigh about 1.67 times 10 to the negative 27th kilograms, while neutrons are slightly heavier, weighing about 1.68 times 10 to the negative 27th kilograms. In contrast, electrons are feather-light at just 9.11 times 10 to the negative 31st kilograms. This stark difference in mass is why the nucleus holds nearly all the weight of the atom. Now, let's talk about some important concepts. The atomic number, as we mentioned, is crucial because it defines the element. But there's also the mass number, which is the total number of protons and neutrons in the nucleus. So, if you take the number of protons and add the number of neutrons, you get the mass number. For example, carbon-12 has 6 protons and 6 neutrons, while carbon-14 has 6 protons but 8 neutrons. These variations are known as isotopes. Then we have ions, which are atoms that have gained or lost electrons, resulting in a net charge. If an atom loses electrons, it becomes a cation, a positively charged ion. On the flip side, if it gains electrons, it becomes an anion, carrying a negative charge. This exchange of electrons is fundamental to how atoms interact and bond with one another. Speaking of bonding, atoms combine to form molecules by sharing or transferring electrons. Take water, for example, which is formed when 2 hydrogen atoms bond with 1 oxygen atom. In contrast, sodium chloride, or table salt, is created through ionic bonding, where sodium donates an electron to chlorine. Atoms are not just a topic of chemistry. They also play a significant role in physics. Atomic and nuclear physics delve into the energy states of atoms, nuclear reactions, and phenomena like fission and fusion. These processes are essential for everything from powering our homes to understanding the stars. Here's a fun fact. Despite being the building blocks of matter, atoms are mostly empty space. The nucleus is minuscule compared to the overall size of the atom. In fact, a single human body contains about 7 times 10 to the 27th atoms. And the term atom comes from the Greek word atomos, meaning indivisible. Ironically, we now know that atoms can indeed be split. So the next time you think about the world around you, remember that it's all made up of these incredible, tiny structures called atoms, each with its own unique characteristics and behaviors. They're the essence of everything we see, touch, and experience.